Hello, I'm Hussein and welcome to my YouTube channel. In this video, we're going to model this boat from scratch in Rhino. I'll try to explain every step in a simple, clear and step-by-step way, so even if you're just starting with Rhino, you can easily follow along and build the model with me. For this exercise, I've prepared a reference image that includes the top view and two side views of the boat. We'll use these images as the foundation for our modeling process. If you'd like to practice this model by yourself later, you can take a screenshot of this reference image right now and use it for your own practice. I've also created a Telegram channel where I'll share the practice files, reference images, and project files from these tutorials. By joining the channel, you'll have access to all the resources, and it will also be easier for us to stay connected. So, if you're ready, let's not waste any time and start modeling. To start, I'll set up the correct units for the project. I'll right-click on Units at the bottom of the screen and select Unit Settings. After the options window opens, I'll change the project units to centimeters, so all measurements are set correctly from the beginning. Now we're going to import the reference image that we prepared earlier. To do this, simply select the image file from your folder, drag and drop it into the Rhino viewport. Then, by drawing a rectangle, you can place the image inside the scene. Before we start modeling, it's better to set the scale of the image correctly. Since the actual length of this boat is 7 meters, or 700 centimeters, we can use this value to scale the reference image accurately. I'll run the scale 3D command, select the image, and define the two endpoints of the boat's length as the reference points. Then, I'll enter 700 as the new length, so the image is scaled exactly to match the real size of the boat. By doing this, all dimensions in the reference image will be scaled proportionally, and we can start modeling with accurate measurements. Now, we need to separate the three views included in this image. To do this, I'll draw 3 lines along the boundaries between the views. Then, using the split command, I'll cut the image along these lines so each view becomes a separate image. This will make the next steps of the modeling process much easier, especially when we need to place each view in the correct position. Now, using Gumball and the Move command, I'll arrange these 3 images next to each other to create our modeling reference setup. First, I'll place the top view on the ground plane. Then, I'll rotate the front view 90 degrees and move it into the correct position. I'll do the same thing for the side view, rotating it and placing it where it belongs, so all 3 views are properly aligned with each other. At this stage, we don't need everything to be perfectly accurate. As long as the views are approximately positioned correctly, it will be enough to start the modeling process. Now I'll select all 3 images and go to the Material section in the Properties panel. I'll set the transparency value to around 50%, making the images slightly transparent. This helps us see the curves and objects we create on top of the reference images more easily while modeling. After that, to keep the project organized, I'll create a separate layer for the images. Before creating the new layer, I'll run the Purge command once to remove any unused layers and unnecessary information from the project. Now, I'll create a new layer called Pictures or Pics and move all 3 images into this layer. This makes project management much easier. Whenever needed, I can quickly hide or unhide these images with one click, or even lock the layer to prevent the reference images from being moved accidentally during modeling. Now, it's time to define the main axis of the boat. Since this model is symmetrical around its center line, having an accurate axis from the beginning will make the modeling process much easier and more precise. First, I'll draw the center line of the boat. Then, based on this line, I'll create a vertical line as well, so we have a proper reference in the other views. Now, I'll temporarily unlock the image layer and slightly move the side view until the symmetry line of the image matches the main axis of our project. After adjusting it, you can lock the layer again to prevent the images from being moved accidentally. Now we can start modeling. The first important curve we need to create is the main hull curve of the boat. For this, I'll use the control point curve command and draw the curve in the side view, trying to match the shape carefully with an appropriate number of control points. For now, we won't focus on details like the front extension of the boat or the vertical column. At this stage, we only need the overall shape and the main hull curve, because the rest of the model will be developed based on this curve. If you notice in the perspective view that the curve is not exactly placed on the axis, select it and use the set XYZ coordinates command to adjust its position so all points are aligned on the y-axis. This ensures that the model is perfectly symmetrical from the beginning and helps us avoid problems in the later stages of modelling. Now, we'll move on to the second curve. This time, we'll draw the lower half of the boat from the top view. Just like we did in the side view, I'll use the control point curve command and draw the main plan curve directly on the reference image. After creating the curve, some points might be placed at the wrong height because we are working in a 3D environment. To fix this, I'll select the curve and use the set XYZ coordinates command to place it on the correct plane. Now, since the endpoints of the two curves are not exactly connected, we need to make a small adjustment. By selecting the curve, the control points will appear, and we can move the endpoint control points until the two curves connect perfectly. At this stage, there is an important point to consider. The curve we created from the top view is completely flat at first, but the actual boat hull has a curved shape. To create this curvature, I'll select the control points of the curve and move them along the z-axis to match the reference image and create the correct form. Whenever a point reaches the correct position, I'll deselect it so I can have better control over the remaining points and gradually move closer to the final hull shape. We'll repeat the same process for the side view. Here, I notice that the reference image is slightly larger than needed, so I'll use Gumball and its scale option to adjust the image size and make it match the curves. We also need to remember that the reference image only shows the upper part of the boat, which is the section above the waterline. However, in the actual model, a part of the hull is below the water surface, and it has a different curved shape. To create this lower section, I'll use the control point curve command and draw the bottom profile of the boat. Then, I'll remove the unnecessary parts and adjust the curve at the center of the file, where the strongest curvature exists. Finally, using the move command, I'll adjust the curve so the connection points align perfectly, and the overall hull shape will be ready for the next stage of modelling. Now that we have the three main curves, the plan curve, and the two profile curves from the different views, we can create the main surface of the boat hull. For this step, I'll use the network surface command and select all three curves. Using these curves as guides, Rhino will generate a surface that gives us the initial and basic form of the boat hull. Since the boat is symmetrical around its center axis, we can use the axis we created earlier and mirror this surface using the mirror command to create the other half of the hull. After creating the second half, I'll select both surfaces and use the join command to connect them together and create one continuous surface. To add thickness to the hull, I'll use the offset surface command. First, I'll check the offset direction. If the direction is not correct, I'll use the flip all option to reverse it. Then, I'll set the thickness value to 2 centimeters. Now, we'll move on to creating the edge of the boat. I'll take the curve we created from the top view, mirror it again, and use the join command to connect the two halves and create a complete boundary for the upper edge of the boat. Then, using the offset command, I'll move this curve 5 centimeters outward and 5 centimeters inward. These two offset curves will be used as references to create the boat's edge. Now I'll use the loft command to create a surface between these two curves. After that, with the extrude surface command, I'll extrude this surface by 5 centimeters to create the required thickness and height for the edge of the boat. Once this part is created, I'll delete the previous base surface. At this stage, the edge we created is still not a single unified polysurface and is made of several separate parts. To make it easier to manage, I'll select all 3 parts and use the group command to place them into one group. Now, we'll move on to the outer part of the hull, where the boat has grooves and rows that look similar to wooden panels. To start, I'll use the duplicate edge command to extract a curve from the upper edge of the hull. Then, in the side view, I'll use the polyline command to create a cross-section with a thickness of around 10 centimeters that follows the shape of the boat's edge. The purpose of this step is to provide Rhino with a more complex profile instead of just a simple line when using the network surface command. This allows the generated surface to have a more natural shape, similar to the wooden layers and grooves on the hull. After that, I'll use the set XYZ coordinates command to place this section exactly in the correct position. Now, I'll hide the original curve, join the new lines together, and run the network surface command again. As you can see, this time, the generated surface has a more natural and realistic form compared to the previous version. Now, let's move on to creating the column or main support axis underneath the boat. First, I'll isolate the line that we created earlier in the side view for this part. Then, using the polyline command, I'll extend it slightly to create the required shape. After that, I'll use join to combine the lines into a single continuous curve. Next, I'll create 2 offsets from this curve, one 5 centimeters outward and another 10 centimeters inward. Then, using the control points, I'll adjust the shape of these curves until we reach the desired form. Now, I'll connect the start and end points of these 2 curves to create a closed cross-section. To make the shape more realistic, I'll smooth the corners using the fillet command with a radius of 2 centimeters. After that, I'll extrude this section in both sides mode with a thickness of 5 centimeters to create the initial volume of the column. At this stage, some edges might slightly extend outside the hull. To fix this, I'll first redesign the curves. I'll start by using explode to separate the curve elements. Then, with the rebuild command, I'll set the number of control points to 15 giving me better control over the shape. After that, I'll move the inner edge slightly inward to increase the thickness of the main column and create a better connection with the hull. Finally, I'll join the curves again, refine the corners with fillet, and this time extrude the section with a thickness of 3 centimeters in both sides mode to complete the final form of this part. Now, we need to fix the areas where the main column intersects with the boat hull. For this, I'll use the Boolean split command to separate the intersection area between the column and the hull. If the command doesn't work correctly, it usually means that the two objects do not have enough intersection. In that case, I'll slightly move the edge of the column to create a complete intersection, allowing Boolean split to perform the cut properly. After the split is completed, I'll ungroup the object so I can select and remove the unnecessary parts. Finally, I'll select the main column and the boat edge again, and use the group command to combine them into one set, making them easier to manage. Now, let's move on to creating the floor of the boat. For this part, I'll create a simple rectangular surface that is slightly larger than the dimensions of the boat. Then, I'll place it in the correct position. I'll unlock the hull surface and use the split command to cut the floor surface based on the shape of the hull. After the split, I'll remove the extra parts so the floor matches the inner shape of the boat perfectly. At the rear section of the boat, there is a wooden panel that we also need to create. First, using the control point curve command, I'll draw the upper half of this shape. Then, using the center axis we created earlier, I'll mirror it to create a complete and continuous curve. Next, I'll use the polyline command to create a closed boundary around this shape. I'll join the lines together using join, and then use planar curves to convert it into a surface. Now I'll place this panel in its correct position, rotate it slightly to match the angle of the boat, and use extrude surface to give it a thickness of 5 centimeters. Then, I'll use Boolean split between this volume and the boat hull and remove the unnecessary parts so it matches the shape of the hull perfectly. Finally, to prevent overlapping surfaces, I'll use the explode command to separate the object into individual parts and remove the extra outer surfaces, leaving only the inner layer. Now, we'll move on to creating the internal supports of the boat. To create these supports, I'll use the contour command. First, I'll select the longitudinal direction of the boat and set the distance between the sections to 50 centimeters. This will create the required cross-sections along the length of the boat. Now, to convert these sections into usable profiles, I'll use the offset command. With the cap flat option enabled, I'll give them a thickness of 2 centimeters. Then I'll extrude these profiles in both sides mode by 1 centimeter on each side. This creates a total thickness of 2 centimeters and forms the internal supports. Now let's move on to creating the seats. For this part, I'll use the rectangle command to create several rectangular boxes. I'll set the width of these boxes to 10 centimeters and their length to around 3 meters. Then, I'll extrude these rectangles by 5 centimeters. And use the inner surface of the boat with the Boolean split command to cut them, so they perfectly match the internal shape of the hull. Next, we'll create the paddle holders. First, I'll draw a circle with a radius of 4 centimeters. Then, using the offset command, I'll create a 1 centimeter gap. After that, I'll use the polyline command to add a triangular section to this shape. And use mirror to create the symmetrical side. With the trim command, I'll remove the unnecessary lines. Smooth the corners using fillet. And finally, extrude this profile by 2 centimeters. Now using the align command, I'll place this piece on the edge of the boat. For the other side, I'll use mirror to create the symmetrical copy. Now we'll move on to creating the paddles. For this part, I'll use sub D, because it is a great option for creating smooth and organic shapes. First, I'll create a sub D cylinder with a radius of 2 centimeters and a height of 250 centimeters. By pressing the tab key, we can see the smooth sub D form of this object. Now, while holding Ctrl and Shift, I'll select the end edges and faces and use the extrude face command to extend the end section of the paddle. Then, by adjusting the sub D controls and modifying the control cage, I'll shape the blade of the paddle. Finally, I'll place the paddles in their correct positions on the seats and inside the paddle holders. I'll also rotate them slightly to create a more natural arrangement. To increase the length of the paddle handle, I'll select the end edge and move it about 1 meter to reach the required length. Now, the modeling process of the boat is complete, and we can move on to adding materials. First, to organize the file better, I'll create a new layer called curves and move all the construction curves and guidelines we used during the modeling process into this layer. Then, I'll hide this layer to create a cleaner workspace. For the wooden parts, such as the internal supports, edges, and seats, I'll create a wood material. In the bump section, I'll add a wood texture to create surface details. And in the color section, I'll use a light brown color to achieve a more natural wooden appearance. For the exterior hull, I'll create a light blue or turquoise material. Again, I'll use the same wood texture in the bump section to keep the feeling of painted wood and preserve the surface details. The floor of the boat will also use a wooden material. And with that, the final boat model is complete. Well, in this video, we modeled a boat from start to finish in Rhino. We started by preparing the reference images and setting up the correct scale. Then, we created the main curves, built the hull and different details of the boat, and finally completed the model by creating and applying materials. I hope this tutorial was helpful and can support you in improving your 3D modeling skills and using Rhino more effectively. If you found this video useful, I would really appreciate it if you could support the channel by giving this video a like. And if you haven't subscribed to the channel yet, you can subscribe to stay updated with future tutorials and follow along with the next projects. If you have any questions, suggestions, or feedback about this tutorial, feel free to share them in the comments section. I'll do my best to answer your questions whenever possible. Thank you so much for staying with me until the end of this tutorial. I hope we can learn together again in the next videos and create more interesting models. Until the next tutorial, take care and happy modeling. Goodbye.